Okay, we are officially in National Engineering Week. For those that don't know, Engineering Week is a week across the United States where colleges and high schools showcase engineering. The goal, of course, is to encourage you all to be engineers. So I have three engineers with me from industry, and you can state your names.
My name is David Henderson, retired aerospace engineer.
My name is Joe Consien, and I'm a chemical engineer and spent my career in the crude oil refining business.
And my name is Logan Straley. I'm an engineering intern as well as an engineering student.
All right, and I'm of course Mr. Reeves. You all know me from downstairs, STEM community, Project Lead the Way, and I'm also a computer engineer by profession as well. So, with Engineering Week, I have a lot of students, and one of their main questions is, what do I do with this degree? Why go to school for it? Other than the money, what's some other reasons why you're in school for engineering right now?
It is enjoyable. You really just get to see how everything gets put together. It's not so much about the money. I mean, when you enjoy what you do every day, it just makes everything so much better. You can actually put effort forth and not really have to worry about, hours spent doing it or anything like that. It's just very rewarding, just you get a problem and, most people can't solve it. So getting the opportunity to know how to solve it and what exactly it's going to do is it's really rewarding.
Okay, why did you all become engineers?
Good question. I was very undecided in high school about what I wanted to do with my as far as making a living. My father worked at a crude oil refinery, and I was lucky I was able to see what engineers do. And really, I started out in engineering school just wanting to be my father's boss is really what I did. And I learned later that engineers is a wonderful field where you can, if you're like math and science, you become a problem solver along with other people. And I think that describes it best of all. It is a good career to make a living, a solid way to make a living and support a family. But it's also a very rewarding career from a standpoint of problem solving and just expanding your own understanding of the natural world, no matter what field you're in of engineering.
Yes, sir.
Okay, my name's David Henderson. Like I said, I was in aerospace for 42 years, and I was an airplane rocket nut from the time I was 4 or 5 years old, and I got into general aviation and did a lot of flying, and finished in physics and aeronautical engineering, and went to work as a aerodynamist, and then I was also in aerospace. I spent 3 years at Vandenberg tracking vehicles, satellites, and anyway, I have a lot of sympathy for the importance of the young people going into science, because it's just like medicine. When you go into medicine, there's many different ways you can go, into pediatrics or whatever. In engineering, in my particular case, it was a lot of aerospace heavy, but all of that mathematics that you learn can find applications far beyond that, and I highly recommend aerospace engineering. However, it's up and down with the politics, and but I think that if in the future we're going to go to Mars, we need a lot of help.
Yes.
We need a lot of new stuff before we can do that, and so now I turn it back over for questions or whatever.
Well, it's funny you mentioned Mars. That's one thing that I've found. Of course, we're very close to NASA. They're hiring more astronauts. And this will be the generation that goes, the ones that's in school right now. So, again, we are encouraging you all to consider engineering. Another question I'm asked a lot is, why is it so much math? Why is it so much mathematics? Anyone care to address that, or as far as how much math do you actually need?
I will address that. It just so happens that math is the language of nature to a large extent. I am not particularly good mathematician. I am a persistent mathematician, but not particularly gifted in the field. And that's just the nature of learning about our world around us. It just seems that numbers describe the world around us. So I would not let mathematics scare me off. If I'm, all you have to have is a good, persistent attitude toward mathematics and some basic aptitude there. And so it is important, but I would not let it scare me off. Mathematics does teach one other thing that I think is extremely important, and that is the technique of problem solving.
From a college student aspect, that's entirely correct. Math might intimidate some people, but it takes a lot of dedication, and once you get the hang of it, it's actually pretty simple. And being an engineering intern, I use it quite often to solve stuff to do with the wellbore schematics. You drill a hole in the earth, and you have to figure out deviation, and everything is that, and it's all math. When I was in high school, I didn't take any math. I just basically had senior release and got out early. I wish I did more in high school, but when I got to college, as soon as you study and you start working things out and you just realize how important it is, it just becomes like a second nature.
Yeah, and I just have to reiterate on what they've said. Please, as young people, don't let anybody frighten you off of mathematics, because once I did a lot of work in various fields of astronautics and aeronautics, and once you find out how things work in mathematics, you say, well, why didn't I know that before? It wasn't near as bad as it was made up to be as a student in say, algebra and calculus. So please, mathematics is a tool, just like a tractor that you use to plow the field. You can run the tractor as well as somebody else can.
Absolutely.
So that's my comment. Don't be afraid of math, because once you find out what it's all about, it ain't that bad, okay?
Another question I'm asked a lot is, why do I need a blueprint? Why do I have to spend time and making my head hurt to design things instead of just getting the materials and trying to build it? Anyone want to?
Well, from a student aspect, working in the industry, I've constructed blueprints like 3D modeling on the computer. I actually haven't had to draw one, but I spoke with some of my superiors, and hanging in their office is detailed drawings of such things like spark plugs, tools in the oil industry. I mean, I can see how that plays a big importance to the field. I mean, just designing it right, making sure you have everything laid out. It's measure twice, cut once. You don't want to take and build something, then have to tear it all apart just to redo something that was incorrect the first time.
I would say two things as it comes to a blueprint. A blueprint is a plan, and I think engineering, for me, I was in the for-profit part of engineering in an oil refinery, and I lived by the rule: make a plan, work a plan. And that was my motto: make a plan, work a plan. The other thing that I found out about a blueprint before we had AutoCAD and other things was, if something can go through my finger and I can make it, it can then circle like through my brain. And so to me, making that blueprint was, if you can draw it and you can put it on paper, you've got a good chance that you can build it.
Yeah, in a similar light, engineering, this is what engineering is all about. You build something, and then you figure out whether it's going to work or not by blueprints and other analysis. For instance, we went to the moon thousands of times on the computer before, and we went to the moon. We made all of those mistakes in the blueprint, how you get there, and the gravitational attraction of the moon, and all the motion analysis. And you just, in engineering, you just have the opportunity to make it work. And this is especially true when you're working with manned space operations. You can't do anything without a lot of testing before you put human beings into these machines. And right now we really need a lot of work before we can go to Mars. and there's a lot of publicity about it. And I wish I had seen that movie, which I didn't get to see. I understand it was a very good film, but don't let anybody tell you that we know what we're doing, because in most cases we don't know what we're doing, but we got an idea and we can go try it with blueprints and analysis and planning. So don't let anybody tell you that, hey, we know everything there is about the world. Boy, they're telling you a big lie, because we don't. We simply don't know. We need young people to, like Einstein said, you stand on the shoulder of giants in order to get where we're going to go.
Exactly. So we really do need you guys to major in engineering. I'm always pitching that because it's my field. I love it. I did computers as well, computer engineering. The thing that really attracted me most with computers is they're forever changing. They used to be big as this room we're in now, and now they're small as a laptop. They're even this small as this audio device right here, and getting smaller. For all of y'all that have an iPhone, that is actually a computer. It's not just a phone. Just some people did not know that. Some students didn't, but yes. Another question I'm asked as well is, will my classes from here, how do they relate to my college classes? Meaning, if I would learn something from here, would I actually be able to use it in college, or is this just for high school?
In regards to that, everything you do in high school translates into college. Like I said before, I had senior release in high school, and it basically gave me a disadvantage because when I came to college, all the students I was in with in college had already completed everything in high school, so they knew exactly what was going on. Basically, your whole freshman level engineering classes, you're going to have Cal 1, Cal 2, electricity and optics, mechanics. All that can be taken while you're still in high school. So if you want to get a jump start and you're afraid it's going to be horrible, you can take it in high school, and it's going to, it won't really affect you as bad, but it'll only give you a head start. It can only help you. Most people are intimidated by, your first semester, it's all math, all physics, chemistry. It's really not that bad. If you pay attention your senior year and you do what you're supposed to do and have a plan, you can just breeze right through it, and you can learn so much. They really, in high school, they really try to set you up that way your college career can be as easy as possible. It's just all up to you on how far you want to go.
Shows you how much things have changed over the years. What you've just described is an ideal situation. You get some calculus, maybe a good solid calculus background in high school. I encourage you so much to pay attention and to really understand and learn your math that you're taking in high school, because in my particular case, I only took through Algebra 2 in high school. And I was so concerned about that when I went into college, because I hadn't really, tell you the truth, I really didn't pay attention in high school as much as I should. I just learned how to pass a test. And when I got to college, I retook Algebra 2. Before I got into calculus, many of you would start at second level calculus or maybe calculus 3 in college. It's so different, and all I can say is that your high school preparation is directly transferable in math and science to your college courses.
Yeah, I can say a few things too, that most of the mathematics that we work with, as a student, you'll be astonished, was really developed from Newton in 1643 and on into the 1700s and 1800s. Most of the big mathematical problems were solved before we had satellites, before we had radio. So you'll find out that, hey, people have been learning calculus ever since Newton wrote it down in 1643.
Okay, one more question. Now, we've gave them all the educational stuff, all the advice to encourage them for engineering. What are some fun projects you all have done in your careers and doing now?
In college, for one of my engineering classes, we had to construct a pneumatic cannon, basically a giant potato gun, but we used it to fire tennis balls. So, doing that, it teaches how to use, AutoCAD. You have to, start out brainstorming, draw a plan. That was actually pretty fun. I learned how to do 3D modeling in CAD. in the industry, I've actually had to construct wellbore schematics in the computer, which is basically a 3D image of a oil field in the ground and the stuff that's downhole, such as your tubing and your casing. And to see, you take a sheet of paper with everything listed, and then you get to go through and finesse it and then input it in the computer. When you see something pop up, it's extremely cool just to realize that all your calculations were correct, and hey, I did this, and it's just awesome.
Works. And it works.
Oh yeah, it works. It's in
works.
production. It's in the field being used.
Oh, yes.
That's the satisfaction when you do something and it works.
Yes.
I would say for myself, one of the most interesting things I did is the company I was with decided they were going to purchase a huge processing complex in Freeport, but they didn't want to run it in Freeport. They wanted to run it in Texas City, and so I was given the job, or my staff was given the job of moving this $300 million project at the time, from Freeport to Texas City. And just the logistical challenge of doing that and then starting it up successfully in its new home was a great amount of satisfaction, and you wouldn't believe it, but a tremendous amount of enjoyment to me. That was I felt like I had done something to deserve the engineering title, I guess I would say.
Yeah, and it brings to mind, I worked on very many very interesting. I'll just make it short. One of the first, we worked we were in supersonic aerodynamics on the supersonic transport, and we had a large computer system for the first time that could simulate the motion of the air around an airframe, arbitrary airframe, by breaking it up into little squares called finite elements. And we were able to make basically a wind tunnel out of the computer and do it 24 hours a day. The other project I worked on, which has got a little bit of publicity today, is, we got another planet out there somewhere. I worked with those fellows at JPL where we did multi-body gravitational simulations of the solar system. And you involve mathematics where you can guess that there may be something else causing the errors that you see in the motion when you compare it with observed results using astronomical measurements. And so that is a very interesting project. It made the news lately. Oh, we got another planet out there. Well, that's come from the analysis of the motion of all of the bodies in the solar system, including all of the satellites of the big gas giants.
Oh, all right. Thank you guys for coming, and tours. Enjoy the rest of your engineering week.